Alright, today, as it says here, we are looking at dilations and reflections. So we'll start with dilations first. And first up, we're going to look at dilations from the x-axis. Alright, so from the x-axis, so for example, if say I've got a graph that looks like that, and if I've got a dilation from the x-axis, that means I'm moving up. Now in a dilation, I would have dilation by a particular factor, of course, so everything might be, 2 times or 3 times. So the question is, though, what's changing here? So if we're going down here, just these vertical lines here, so what's actually changing, excuse me, is not the x value, but the y value. So the y value has changed from here to here. The y value's changed from here to here, here to here. So, excuse me, when it's a dilation by multiplied by a factor. Is what we're looking at. So if you have a look at this, here we go. So have a look at this particular graph that I've got up here that I've done on the calculator. So at the moment, the blue one is just the square root of x. The green one is 2 times the square root of x. So if we isolate a point, so here for example, x equals 1, so the y value is 1, and for the green the y value is 2. If we go here, for the blue, 4 square root of 4 is 2, but you see again up here straight up, it's 4, which is 2 times 2. So each of these points is all 2 times, all right, stretched up. So it's by a factor. So in terms of, let me just erase a little bit of that down here, give me some space. So if we look at what changes, so if we've got looking at our mapping again, so we've got our original x and our original y, and what happens to that? Well, our x stays the same, but our y becomes bigger by that factor. So I'll call, say, ay, for example. No, I won't. I'll use b. I'll be consistent with your textbook. So they use b. So by. So this is our image, and this is our image. So when we're talking about our image of x, it's just the same as the old x, but our image of y is some factor times the old y. All right, and so we're probably used to seeing that a little bit. But what becomes interesting is, get rid of that one. So here we've just got our, what becomes interesting, and this is the tricky one, is when our next dilation. And so our next dilation that we're looking for is from the y-axis. All right, so let's go back to that I had. So here we are. So take, for example, this one here. Now I've got a 2 inside the bracket. And when you have a look at that, when we graph that, let's see what happens. Now, kinda, it's a bit more difficult to tell. So, when, let me put this one up. So with that, it was simply, 2 times bang, 2 times bang. But now with the red one, let me get rid of the green one again. But the red one, it's not a matter of 2 times and it's up. But when you come here and you have a look here, let's look at the 0.11. So that point right there. So the 0.11, when we're looking at that, and then we come to the red one, that kind of looks like it's halfway. So it looks like it's 0.5 for the x and 1. Right, let's have a look at another one. So this 4 here. So 4, square root of 4 is 2. I want to come with the blue one down here. The x value is now 2. So both of these look like they've been pulled down here. Now I can drag this over in here for 9. So 9, where are we? No. Yep, so here we are, 9. Square root of 9 is 3, so you're up 1, 2, 3. But for the red one, when you come down here for the x, it's 4.5. So what's looking like here is that with this dilation, with having this 2 in here, it's not actually moving it away from the y-axis, it's moving it towards. It's moving it towards, well, halfway, isn't it? So it's a little bit trickier with dilation from the y-axis. So this 2 here actually is a dilation from the y-axis, but it's a dilation of factor half, not factor 2, unlike the green one that we looked at before. So your dilation from the y-axis, so when we look at this, what I had before, go here, it actually comes back in this way, like so, to be there. So by this one here, we'd say it's a dilation from y-axis by 1 on whatever our factor is. And in your textbook they use a as the factor, so by 1 on a. But how does that look in terms of your your intercepts, or your x value I should say? So let's go back here. So looking at our x value, so our old x is now our new x's. So to get the same y value, so to get the same y value for our translated 1, to get the same y value, so let's choose this one. So to get the same y value on our red one, what did we need? We needed 2 here. So what have we got to do to this x value? We've got to times it by 2 to get what the old one was. All right, so our translation here for this one here is, if we take twice the old x value, we get the same y value. All right, so it pulls it down here. So to get this y value here, we have to take twice this x value, 2, to get the same y value. So, whoops, wrong. So x dashed and y dashed, they're our images. So in the mapping thing, our new x is twice what the old one was. And our new y is the same as the old y. So our new x is twice what the old x was. So our new x is twice what the old one was for the same y value. All right, so that's a little bit tricky. All right. So you need to be careful with that one. All right, so dilation from the y-axis is always one that gets people confused. And we'll get to a question in a minute where I'll do an example where we've got a dilation from the y-axis, and we'll look at how we'll go about it. All right, so now I've just written all of that underneath without moving those calculators. All right, so we take our x, we multiply it by some factor, so 2x in that case, but if our factor is factor a, then we multiply it by our a, and in terms of that then translates to a dilation on the y-axis by a factor of 1 on a. So the one that we had was y equals root 2x, so that's a factor of half, so it brings it in. All right, the next thing is reflection. So reflection in x-axis. So here's our x-axis, here's our new one. Going to reflect it in our x-axis here. So if we reflect it in our x-axis, that brings that point to there. So it reflects around. And this point here gets reflected around to there. This one gets reflected around to there. So we end up with something that looks like that. So what changes? Well, what changes is the y goes from there to there. So it's from some positive number to some negative number, and it's exactly the same number. So it's a plus y and that's a minus y. So in terms of our mapping transformation, our x stays as it is, but our y becomes negative. So remember, that's our image. So in terms of our images, the old x and the new x are the same, and our image of our y is just the negative of the old one. All right, and reflection in the y-axis. Again, it's something goes like that, and then we reflect, and we reflect this point in the y-axis. So we reflect it over there. We take this point, reflect it over there. So we end up with something like that. So what's happened? What's changed here is our x has become negative. So in terms of our mapping, our old point to our new point to our image, so the x values become negative for our reflection in the y-axis. So our image x is the negative of the old x, and our image y is the same as the old one for the reflections. All right, spare page there, here we go. So determine the rule of the image when the graph of y equals 1 on x squared is dilated factor 4 from the y-axis, from the x-axis. Okay, so let's look at A first of all. So our old x's and y's, if we're moving from the y-axis, so from the y-axis, what happens? So when we come here, from the y-axis, whoops, here we go, dilation from the y-axis. All right, so from the y-axis, what's going to happen for our image? So here we go, we've got a factor, and A is our factor here. So from the y-axis, it is our x that changes, and it will be 4x and y this time. All right. So our image, and our image of our X image is 4 times what the old X was. And our Y image is exactly the same as our old one. Now, if I need to divide by 4, so our image over 4 is what the old X is. And the reason I need to do that is because we've got our equation 1 over X squared. And so this is the old one. So these X's and Y's are the old ones. And so I need to replace these X's and Y's by the expression that has the image in it. So for the Y, it's just a straight substitution. But for the X, the old X with the image in it is that. So we've got 1 over X on 4 squared. All right, so I need to go, oops, X dashed on 4 squared. So I need to go to the next page here. So I've got Y dashed equals 1 over X dashed on 4. Oh, that's terrible. X dashed on 4, and we've got to square that. So Y image is 1 over square X dashed, you get X dashed squared. Square 4, you get 16. Now if we're dividing by a fraction, we can flip it and multiply. And so our image then for A is Y equals 16 on X squared for that particular one. All right. The next part B, says from the X-axis. So remember what changes when we go from the X-axis. So B from the X-axis. So from the X-axis, what changes? What changes is the Y value. And so the Y value gets bigger by the factor, which is 4. And remember, that's our image, that's our image. So X image is the same as the old X. The Y image is 4 times the old Y. And so what I need to do in my Y equals 1 on X squared, I've got to replace, because this is the old one, I've got to replace by the expression with the image in it. So I need, for the Y, I need to divide by 4. And so what I've got here is replace the Y by Y dashed on 4. Replace the X by X dashed and square it. So we've got Y dashed on 4 equals 1 on X dashed squared. And now if I times both sides by 4, I'll get that Y dashed equals 4 over X dashed squared. And so our image is 4 on X squared. For our image of this particular truncus is what it is. All right. So the only one you really got to be careful with is the dilation from the y-axis. And if you treat it in that way that I've done here with this here, if you treat it like this, then you'll get it right. So it's the only tricky one because it moves at the opposite direction than what you would expect. So when it says factor 4 from the y-axis, it's actually squishing it in. All right, so that's that. If you've got questions, make sure you get some help from me. So we're looking at exercise 7B, questions on your work plan. From that. All right, so good luck with all of that.